Hey everyone, how are you? Welcome to our series of short notes, right? Now, you asked for it, right? You were asking for a couple of days. So class 8th ka hoga, class 8th, we are here, right? So I told you before also. So when we have said we'll come with class 8th, we are here with class 8th. Hello Pooja. Ramesh, Nikhat, Purva, I think I have seen you somewhere before. Hey Aman. Good afternoon, Adira. Guys, come on. I mean, I'm here, but I can see a lot of your friends are not here. Come on, call them up. Nikhat, hello. Rudu's Imaginative Corner. It's a long name. Alright, hello everyone. Thank you, Hema. I mean, yeah, I often tend to forget to ask this. I mean, I forget to ask this. Yes, thank you. I'm clearly audible. I'm clearly visible, which means we are good to go. Good afternoon. Good afternoon. Almost evening. All right. Yes. Today, the session is explore everything about light. All right. So this is light we are talking about, and it's a very fun kind of session. I mean, the reason is there are experiments in this session. There are activities in this session. There are simulations in this session. One for me, one for you, and we also have few questions and a lot of mind maps. All right. So it's a very fun packed session. I want you to be attentive. I want you to be interactive, and we'll enjoy the session. I'm pretty sure. Thank you, Aishwarya. Oh, clearly visible at nice. Hey, Maria. All right, guys. Let's start then. I mean, let's not waste more time. It might be a little longer than you might expect, right? 40-45 minutes. Yes, we got you covered. All right. So, let's start with light. You know what? Whenever we are talking about light, there is going to be talks about darkness as well, right? I mean, where there's light, there's darkness. So, are you scared of dark? I mean, when I was little, I was, and I was afraid to go out at night. If I tell the truth, see, that's my truth. When I was small, I was afraid to go out at night. I mean, I was scared of dark. I mean, and that's I feel a lot of you might as well, right? So, and let me just tell you, I'll do one activity over here. Long ago, before we all, started thinking scientifically, people used to believe that humans or any animal, I mean, we are a social animal, right? Any animal used to see things by emitting light from their eyes. Their eyes used to emit light. All right, so this is my argument. I'll give what they thought in support of this argument, and I want you to give arguments against this. All right, shall we do this activity? All right, Fun with Girls is not afraid of dark. Nice. Brave kids you are, huh? All right. So, shall we start? First of all, I'll tell you why people thought that animals emit light from their eyes. First of all, the first reason they gave was, have you ever looked at the eyes of cats at night? You might have noticed they glow, right? Eyes of cats glow, which gave a feeling it might be they are emitting something, right? So, this is my argument first of all. What do you think? Come on, let's do this activity. I told you, this session is not like one-to-way communication. I'm going to ask something, you can contradict me. Very well. Let's think. Come on. Do we really emit light from our eyes? Okay. All right. Come on. Yes. Come on, guys. Give me good answers. All right. I'll give you one more thing. They believed light was coming from the eyes. It glows, right? Anirudh is saying it glows. Yes. Because they reflect light from eyes, Kunal is saying. Okay. Can someone give me an argument, only one statement, which will discard all these arguments? Only one argument. I mean, if it was true that our eyes really emit light, something should be possible. Come on guys, think. Let's be scientific over here. Oh, hey Papia. It's okay, you didn't miss anything. We are just doing an activity over here. I'm telling that humans or any animal emit light from their eyes? Nice. Fun with colors has given a very good argument over here. If we close the light, then we will not be able to see. Okay, alright, yeah, this is good. Very good, Umar. Nice. We should see in the dark. I mean, if really our eyes emit light, why can't we see things in dark? We should be, right? That's a perfect argument. And that's why you all need torches. I mean, it's a dark room. You need torch so that some source can produce light and then you can see things, right? Yes, we should have been seeing things in dark. Very good, Kunal. Nice, nice. Nice, guys. Very good. So, this was the end of the argument, right? Which means, no, we don't emit light from the eyes. We need external light to see things. Perfect, right? Very good. Nice. So, what do we need? I mean, if we talk about a natural source of light, we have an ultimate source of light and heat and energy. We call it the sun. And it's like good morning. When it's good morning, there's light everywhere and we see everything, right? That's how we see colors. That's how we see the world. So, first thing is clear, we need external source of light. Fine. And this is our first thing. That's how we start. Light. Alright, guys, let me just tell you, in this session I would want you to be ready with your pen and notebook. There is a mind map, it's a journey we'll be going through and you will keep noting down the important things. Alright, so first topic is light. Alright, and what did we understand about light? We understood that light enables us to see objects around us. Right, we need external source of light. Very well. In the second animation you would see sun is giving light, it is falling on an object and then it is coming back to our eyes. That's how we see that flower over here, right? Very good, no doubts. Very good, Pooba. Yes. Moon, yes. Moon is reflecting light from the sun. Nice, Pavya. Alright, okay. Fine. So, our first learning is clear, right? We need external source of light. Alright. So, light enables us to see objects around us. One thing is done. That's our starting point. Let's go forward in the journey. The next stop is phenomena. The phenomena which light undergoes. The first phenomenon we want to study is reflection of light. And I'm very sure, you know what is reflection of light. Come on, we all love to look in the mirror, right? So, reflection of light. The phenomena of bouncing back of light in the same medium after striking a surface. This is what? It is reflection of light. Fine. Right. No, moon does not emit light. It is known to reflect the light from the sun. Yes, it's a non-luminous object. Ramesh, you are right over there. Yes? Okay. Reflection, very basic thing. I won't go very much into this. Come on, we have to move forward. So, let's talk about the signs. Let's categorize those important bits. The ray which is falling on the reflective surface is the incident ray. Fine. The ray which is getting reflected back into the same medium is the reflected ray. That is also fine. Alright. Now tell me. Angle of incidence. Yes. Alright. Light bounces back when it strikes on the surface. You're right, Uma. Yes, we have three main things. Rutu, you are right over there. Incidence, reflection and the normal. Yes. The normal is... it is an imaginary ray you draw parallel to the surface. Perpendicular to the reflected surface at 90 degrees. Fine. So, angle of incidence is the angle between normal and the incident ray. Angle of reflection is the angle between normal and the reflected ray. And guys, right now it might seem very trivial. I mean, sir, we know this. But you know what? A lot of times, question is going to confuse you. Question will give you angle from the surface is 60 degree. Find the angle of reflection. And you know what? A lot of times in a hurry we'll answer 60 degrees, but it's not. You have to find angle of incidence. It is always from the normal, right? So you have to say it is 30 degrees, right? So that's how you have to be very careful. Very clear with angle of incidence is from normal, from the incidence ray, right? Yes, angle I equals angle R. That is a law, right? Okay, basic is fine. What is reflection? Bouncing back of light in the same medium. So let's talk about the laws that govern reflection, right? Okay. Yes, Aishi, I can. All right. Yes, angle I is 30 degrees. Pratibha, it might take some time, and I would say, a lot of things are common. So if you are here and if you're able to understand a lot of things, it means you are good to go. Yes, very good, Papia. All right. So I've just written the topic and I can see a lot of you are giving me answers of what are the two laws of reflection. Very good. Okay, Ayushi, you are asking, if you go in higher classes now, you will learn that there are packets of energy, we call them photon, right? So that is what light is made up of. Photon is the word, all right? So come on, laws of reflection. Two very simple laws, and I can see Papi has already mentioned them. The first one is angle of incidence is always going to be equal to angle of reflection, all right? Is it always, or it depends on the surface? Come on, think. I know, I'm just trying to confuse you, but you will give me the correct answer. Is it always, or will it depend on the surface? All right, answer it, don't worry. I'll tell you the second law. Second law is the incident ray, reflected ray, and the normal lie in the same plane. You know what? I'll tell you. If this is the incident ray, this is the reflected ray, and this is the normal, they all will lie in the same plane, means like this, in one plane, all right? Whatever happens, these three will lie in the same plane. Fine. All right. Yes, always. All right. So two laws are fine, I hope. Okay. Nice. Smart kids, always. Which means it won't depend on the surface, right? Nice. So hold it with you. Yes, Omar, you're right. All right, okay. Pratibha, I don't think I'm the right person to comment on this right now, but it's okay. Try to understand what we are dealing with, and if you can, and if you are able to understand well, it means that's fine, right? Okay, come on. Next stop is types of reflection. And guys, if you notice what is happening over here, we start with one topic, we move to a stop. This is what? It's a journey. It's a mind map that we are creating. So what I'm going to do is, I'm not going to give you a mind map, right? Because a ready-made mind map is not very useful unless you make it yourself. So what we are doing here is, we are making a mind map ourselves with each and every stop, with each and every step of learning, all right? So keep making this mind map with you and keep learning. Come on. It's a law, Ayushi. Why angle I is equal to angle R? It's a law. Whenever reflection happens, it is observed. Come on, universal law of gravitation. Why it happens? You try to give something, but it's an experimental observation, and then we make it a law. Tomorrow, if you can find something that doesn't follow it, you can say this law is imperfect, right? Yes. All right. So when you ask me session PDF now, I'll tell you one reason. Session PDF, when I was also small, in college also, we used to take notes in the Xerox shop, right? But that is not very helpful. So what I really want is, when you are learning the session, make notes, right? And what I'm trying to do over here is I'm giving you an inspiration so that you can go and look at the book, and then you understand everything, right? So that's why. Hello, Tariq. All right. So types of reflection. Now, we have already discussed about this. When we were talking about, will it always follow laws of reflection? It will. What is the difference between two images? Come on. I told you, there are some questions which we can discuss. Look at these two images and tell me what is the difference. And come on, be scientific. Use those terms. Nice, Papia. Yes, fun with colors, 5-star class, right? Yes, Andy, you're right. Handwritten notes are best. Very good, Vaishnavi. No, PCM level, today we won't do it. Umar, your question, it's a very valid question. You will learn slowly in higher classes about total internal reflection. But this A mirror does not usually gives you 100% reflection. Some of the light's intensity is absorbed, right? Very good. Regular and irregular reflection. There is a word for it. Regular reflection is reflection of light from a smooth and polished surface. I mean, every ray is parallel. The incident so and the reflected rays also. That's fine. The diffused or irregular reflection. It is the reflection of light from a rough and unpolished surface. And you know what? A lot of times you are watching diffused reflection. I mean, you are able to see me. Yes. Am I not reflecting the light? I am. It is what? It's a diffused reflection. Yes. Yes, water movement. Surface is irregular, right? Divya, that's a very good statement over there, I would say. Nice. All right, okay. So, clear? One more word for irregular reflection is diffused reflection. All right. So, our learning about types of reflection is there are two types: regular reflection from a smooth surface and diffused reflection from an irregular surface. But you know what? I'll tell you one more question. There's one very common question which comes in your classes. Is laws of reflection followed in diffused reflection? It is, because you guys have given me the answer. It is always followed. Whenever reflection happening, the laws of reflection will follow. It doesn't matter. Is it smooth? Is it regular? Is it irregular? Is it diffused? It doesn't matter, right? Irregular, Jitendra. I mean, so you know, the difference you can watch from regular and irregular is very clear. Crystal clear images are formed in regular reflections, right? In diffused, you get blurry images or almost no image at all, right? We are seeing our phone. That your phone is emitting light. It's not reflecting light, right? Why is law of reflection true? So learn with Jatin. It's a law. And we haven't encountered any case till now that it is violated, right? Tomorrow if we can find, we can say it's not true, right? So a law is a law until when it is proven untrue. And till now, none of the cases have proven it untrue. Thank you, Ramesh. All right. So I hope you have noted down this mind map till now. All right. So let's move forward. Next stop is image formation by plane mirror. Now this is very important, I would say. A lot of questions will come from this particular topic. All right. So let's start with image formation by a plane mirror. This is the object. This is your eye. Now, there is one very important tendency of our eyes, and that is our eyes always tend to believe light is coming in straight lines. I'm good, Harvis. Right? So light is coming in straight lines. So when the light from the object falls on the mirror and then reaches your eye tends to believe that it is coming from the back of the mirror. And this is what? It's an image of the object. It's not the object. It is an image of the object, right? Thank you, Umar. All right. So, fine. Okay. Understood why this image is forming behind the mirror, right? Okay. Because in front of the mirror, the rays will never meet. If you take a look, the rays are diverging. They will just go like this. In front of the mirror, they will never meet, right? Back of the mirror, they appear to be coming from a point. That point is what? Image of the object. All right. So, properties of the image formed by a plane mirror. This is very, very, very important. I mean, I can't even tell you how many stars I can make over this. Big Bang Theory. I'm good, Harvish. Virtual and irreal image. All right. So at your level, I'll explain it to you. Don't worry. First thing is, object size will be equal to image size. I mean, when you look yourself in a plane mirror, you see you are similar, right? Very good. Nice, Purva. Right, left, right, reversed. Oh, nice. A very elaborated answer. Nice. Very good. Yes, it is literally inverted. Object distance equals image distance. Object in front of the mirror, that distance is equal to how far image is behind the mirror. Fine. Image is erect, laterally inverted and virtual. I mean, you were right over there. Left, right, reversed, Purva. Left, right, reverse means if I raise my right hand in front of a mirror, my image inside the mirror is raising his left hand. So this is a way of saying literally inversion, and you will see its effects where? In characters, right? Nice. Alright, so these three are important parts. Now, virtual and real. When you ask me, virtual image, there are multiple differences, but I will just first of all tell you, virtual image is something which is forming behind the mirror. Real image is forming in front of the mirror, right? Real images, light rays actually intersect. In virtual image, light rays don't intersect, but they appear to meet behind the mirror. Fine. Yes, fun with colors. You know, that's a very important thing. Why restaurants or many shops tend to install big mirrors? Because it makes their restaurant look big. That's a very good observation. Nice. All right. Okay. Yes, lateral inversion. So, image formation by plane mirror. Three important properties: virtual, erect, same size, and laterally inverted image. Fine. Okay. All right. So, this is how our mind map is forming. Infinite AP all-rounders. All right. Okay. Yes, Adira, you are right. Can be caught on the screen and virtual can't be. Yes, spherical mirrors. Hey Swani, hello. Nice, nice. Erect image. If your object is like this, your image is also like this. Normally, in real images, you will see that if the object is like this, the image is inverted, right? Tariq, don't worry, we'll come to this in the end. Why, you're asking? All right. See, it's infinite because it's a plane surface. When you talk about focus, if the mirror is curved, right? Let's talk about center of curvature first, na? So if the mirror is curved, you would say the center is of the sphere this curved mirror was a part of. But now, if you are slowly reducing the curvature of this will go far. If you make it straight like this, can you say it's a part of a circle which has infinite radius of curvature? And that's why we say, all right? So, I mean, this is out of your syllabus. All right, guys, don't mind. I mean, I know I got distracted over there. All right, come on. Image formation by plane mirror is fine. Now, let's talk magic. Let's talk the real use of reflection. Multiple reflection. Sure, Mritul, don't worry. Okay, guys. Now, I always, my students ask me, sir, we study a lot of things, but a lot of times we don't know how to apply them to real life, right? I mean, a lot of small things are fine. How to create magic with science? I'll show you. You might have seen this on our channel itself. It's a small clip. Come on, watch. It helped me a lot in Diwali, if I tell the truth. How many diyas are there? Come on, think. Watch this. In Diwali, we buy a lot of diyas, right? Because we want to light up our house. How many diyas are there? Come on. All right. And you know what? This is one way of showing it. One more observation I'll tell you. When you go, yes, Adira, infinite. When you go to a barber shop, you might have noticed, you can see there are multiple images of you. I mean, front, back, one more mirror inside, one more mirror inside, one more mirror inside, right? This is all something you have noticed, right? All right. So, yes, Andy. Yes, Papiya, you are right over there. Very good, Purva. Yes. Nice. Purva, you are giving very elaborated, very good answers. Nice. All right. So, I have just given you two observations. The first one was a very fun kind of observation which I used myself on Diwali, if I tell the truth. I mean, it was very nice when guests came to my house and it was like a magic thing. So, science sometimes help us to create magic, right? Why does it happen? Let's observe. If this is the object and this is one mirror and this is second mirror, what happens? Light rays are emerging from this object. Emerging, or you can say from some source, it is falling on the object and then getting reflected back, right? So we'll start with the light rays from the object, okay? First image is fine. We know how it is formed. Then what happens? Image 2, alright. Then another reflection, image 3. And you know what? This keeps on happening. And that's how you get infinite images. Wave or energy is the same thing. If you ask me, is it a wave or a particle? That's where the debate will come in. Yes, Harvish, it happens, but again, I'm not the right person to answer this thing. Alright? Okay. Some observations are answerable with the wave nature of light. Some observations are answerable with the particle nature. But that is, again, that's a very high standard. You have jumped to 11th. Let's come back. Come on, guys. Multiple reflections. We have seen the ray diagrams. Why it happens? A question for you. Can you guess how many mirrors are there in this image? I mean, based on what we have just learned, I can see. You can just give me the answer like this. Come on. Nice 5-star classes. Don't worry. You guys are answering for the question which I'm about to ask. Nice. Alright. Very good. 2. Yes. Because you have just now learned it. 2 mirrors. And yes. Now it also depends on what is the angle between 2 mirrors, right? So, multiple reflection. It's a single mirror, you will see 1 image. Alright, that's fine. Sometimes you can also see these kind of images, like multiple images, right? Yes, you're right. Now, I'll also show you a very small clip that how that infinite Diya was created, and it's very easy. And if you don't know, this is there on the channel, right? If you have not been following it properly. So after this, go and watch it. What is this? A plane mirror you take, then there's a two-way mirror. That's very important. Two-way mirrors in buildings, it's there, right? And then nothing else requires. It's what? You will just see multiple images, and that's very cool to watch. Believe me, I've tried this. All right? Okay. Yes, nice. Umar, don't worry. This theta thing it's not very difficult. It's very easy. We are coming to it. I know what's happening. Yes. On the same channel, this video it's a short video, experiment shorts is there on the channel. Alright, so after the session, go and watch it. And you will get an idea of how to make it also. Alright. So, guys, before the session, I promised, in this session, we'll do experiments. We'll do some magic activities. We'll also use simulations. Alright. It's time for a simulation. I know, you all love simulations, right? So, alright. Okay. Shall we start with a simulation? Alright. So, learning becomes fun. And what I'm going to show you is, we call it an ILE. Alright. So, let's start with an ILE. Fine. Alright. Thank you, Dattatreya.
Change the angle between the
carefully.
mirrors using the slider and observe how
one
it
of these
affects
simulations
the
is for
number
you
of
as well,
images
alright? So
formed.
first watch this so that you can attempt the one which is given to you in the description. Fine. So what is this? It is an observation, first of all. This simulation is meant for your observation. Change the angle between the mirrors using the slider and observe how it affects the number of images formed. Now, Umar, you were asking me, what is theta? Theta is nothing. Theta is the angle between these two mirrors. If this is one mirror, this is another mirror, the angle between these two mirrors is theta, right? Okay. So, first I'll take the slider till 45 degrees. What do you see? You see 7 images are formed. How did you calculate this? There is one very simple formula. N equals 360 degrees divided by the angle between those two mirrors. How much is it? 45. When you do this division, it comes out to be 8. Now, note this down first of all. If n is even, right? If n is even, then number of images will be n minus 1. Number of images are 8 minus 1. That is 7. Alright, okay, thank you Purva. Okay, so 45 is done. So one thing is clear. 360 by theta is the formula for finding number of images. If n is even, I'll do -1. Alright. At 90 degrees, what do you see? Again it is even. Alright. So you again got 360 by 90 will be 4. N is even again. Sir, it means 4 minus 1. That is 3. The answer is 3. Nice. Number of images are 3. Very good. What if this value comes out to be decimal? Then what? Alright, let's check 135. 360 by 135, it is 2.6. The answer would be, number of images are 2. Alright, you'll take the integer value just lesser than that. Okay. Proof, Jatin, you were asking me. This is there in class 11th. Don't worry. And we will deal it again. Don't worry about that. But for here, because I understand it will be a little complicated, but if you really want to try it, you know what? You can start with making ray diagrams. Very easy. Yes. If it is 2 point something, the answer will be 2. If let's say it comes out to be 3 point something, the answer would be 3. Alright. Adira, for now, understand it like it's a formula, right? There are many tricks, there are many explanations, and it's all going to come to you, don't worry. But I won't burden you right now with this. It's there in the 11th. We teach it in 11th, alright? So, fine, okay. 135 is clear. So, 180 will be simple. 360 over 180 is what? 2. N is even again, so 2 minus 1. If you ask me, sir, if N comes out to be odd, I would say same thing, minus 1, alright? There is one more layer to it. I won't tell it to you right now, but understand, even or odd, minus 1. Decimal, just lesser value than that. Papi, I just answered it. Alright? Okay. So, we are done with the ILE. And you know what? After this session, there is one more ILE, interactive learning element given to you in the description. Try that. It's a simulation for you only. Alright? Try it. You will enjoy it. And with each ILE or observation of each ILE, there is a question attached. But you know what? I assume this question is very easy for you now. I mean, if infinite images are formed for an object, then the mirrors are, you know it, parallel, right? Yes. 360 Ayushi again, I mean, because you know, the total angle of a circle is 360. That's why. No, Umar, that's not the reason. Overlapping images come, but I understand at this age and at this point, you know, we are too eager to learn things which are, you know, in higher classes. But I won't. I'll be very strict with this. All right. Hold on. Come on. We have a lot to learn now. Very good. All right. So let's move back to the session. Okay. Yes. So now comes the part. Happy Christmas, I wish. All right. The devices which help us, right? The devices which use multiple reflections. All right. Let's start. One is periscope. Where do we use periscope? I don't know if you have seen war movies where like submarine wars are going, and there was a one very Hindi film, like Ghazi Attack. I watched. I mean, the latest film I can remember right now. Yes, Purva, you are right. Yes. So, periscope device where submarines use it. They bring the submarine close to the water surface and then they look at it like this. You might have seen. I don't know. So, they can see what is above, right, in the submarine. Yes, Soul Gaming, you are right. Navy. Yes. Team Rocket and Pokemon use this thing. Yes. Oh, nice, Jatin. You also watched, huh? So, you know exactly what I'm talking about. What happens in a periscope? Light ray comes from here. It reflects at the first mirror, then gets reflected the second mirror, and then reaches your eye. Alright? This is how you are able to see the things which are above you. You see? It's a very good application of multiple reflections. How many reflections? 2 reflections, right? Yes. Come on, guys, come back. Yes, Pokemon. I watched Pokemon, but it was a long time ago. Yes, at 45 degrees. Gauri Gupta, you're right. Nice. Mirrors are at 45 degrees. Very good. Second is the second application. The second device is something which I understand you have already mentioned in this session. The kaleidoscope, right? What we do? We take 3 mirrors, we put them in a triangle, right? 3 equal mirrors and we put them in a triangle. It's like a liquid triangle. And then what you do? You can see these trippy and amazing images, right? It's a very nice thing. And you know, there are multiple videos on YouTube which will tell you how to make a kaleidoscope. It's very easy. And it's very nice also. I mean, when we were in school, there used to be projects to make kaleidoscope. Right? Okay. So, this is all about multiple reflection. Sanvi, it's not there right now, but I would say, you know, with me, with this session, keep noting down the mind map. It's very helpful, right? Thank you, Nakibor. Alright, cool. So, note down guys, come on. Multiple reflection. Multiple images are formed when mirrors are placed at an angle to each other. Applications are periscope and kaleidoscope. Alright, and after the session, you have 2 things to do now. One is use the ILE. Second is watch the Infinite Diya video, right? You will understand how to make it, exactly how to make it. I mean, you have an idea right now. Alright, next phenomena that light undergoes is dispersion. Now we are talking colors. I mean, till now it was like fine, reflection is there, single light, there was nothing about colors. This is about colors. Now, how do we start with this? What is coming from the sun? So light is coming from the sun, alright. Which light is coming from the sun? Sir, yellow. No, you know, it might look yellow, but it's the white light that we call it, right? And white light is not a single color. Sir, experiment, it's called as, come on, can someone tell me the name of this device over here? Come on. Yes, Purva, I mean, we try, and I'm glad you liked it. Alright, come on. Alright, okay, don't worry, Umar, I'll do it. Yes, dispersion of light. Yes, come on, the name of the device. Yes. Oh, yes, I've got the answer. Nice. Newton's disc. Sanvi is there, Shiv is there, Gauri is there. Yes, it's a Newton's disc. You might not understand or believe this, but Newton has tried this all. I mean, he was there in light, he was in gravitation, he was in Newton's law of motion, almost everywhere, right? So, yes. So, what is the observation? You paint this disc with 7 colors. When you rotate it at very high speed, you will feel all those 7 colors will vanish and there's just one color. It will look like white disc. So that's how we inferenced white light is composed of 7 colors. One more device that help us to see this splitting of white light is prism. What happens? Prism is known. Yes. Not in electricity. Yes, glass prism. Very good. Vibgyor, you're right. Papia, there's no E there. I know it's a typo error from you. I know you understand this. Yeah, Vibgyor, violet, indigo, blue, green, yellow, orange, red. True. Prism does this, right? Prism splits the white light into 7 colors. Nice. So, what are the observations you see? Observations are rainbow happens because of dispersion. You will see compact drives and prism. Now, can someone tell me? I understand you will know this. Rainbow. If I'm saying there is dispersion happening to see a rainbow, is there a prism in the sky? I mean, why is it happening? Come on, think. I understand, you know the answer. Yes. Nice, Purva. Very nice, very detailed, very elaborated answer. Good. Gauri, you have got it correct. Yes, Krish, very good. Ashish, nice. Yes, the water droplets. You might have noticed rainbows usually appear after it has rained, right? There are water droplets in the atmosphere. Those are the ones acting as prisms, right? Nice. Good kids we have. Omar, nice emoji. Right. Why does prism split white light? Jatin, you are asking me, and that's a good question again. So I'll just give you a very quick thing over here. The reason is speed speed change of every color is different, which means bending of every color is different in the refraction, right? So that's why it splits in the case of prism only. All right, again it will come forward, it will come in your further classes, don't worry. 9th and 10th you will have enough of these things. Yes, Gauri, you are right, due to different velocities. Yes. All right, okay, so we are done with dispersion as well. Fine. Splitting of white light into its component colors. Fine. This is what? Dispersion. All right. All right. Again, I would say, I hope you are making this mind map, right? It's very important. Okay, we started with light. We went till reflection. One more phenomenon is dispersion. Reflection, we have subparts like laws of reflection, types of reflection, image formation by plane mirror, and multiple reflections. All right. And in dispersion, we have discussed splitting of white light into component colors. All right. Fine. Now, let's come to our own biological optical devices. I mean, in our body, I mean, I have an extra one, but in our body, there are two important optical devices. What are those? Our eyes, right? Everything is in 9 to 12th. Huh? See, I understand. In the lower classes, we feel like we are getting bits and pieces of the information. But you know what? That's a good, this is how you build up the knowledge. You come with this much and slowly you keep on adding more and more knowledge to it, right? That's something which is very important. And that's why if you're not clear with the basics, you will struggle in further classes, right? Very important. Eyes have lenses, you're right, right? Interface, yes, you can say interface. I mean, what is interface? Between two media, there is a layer, there is a separation. That is the interface, right? There are things. All right, so let's talk about human eye. All right, come on, very quickly, let's discuss the parts. What is there? You told me there is a lens. Yes, there are lenses. Yes, okay. We have cornea, the uppermost layer of eye, right? The uppermost layer of eye is cornea. All right. Pupil is that small hole. You might have seen when you look at people's eye, right? There is a small hole in between. In dark, it becomes bigger. In bright light, it becomes smaller, right? Yes. Crystalline lens. Umar, you're right over there. Yes. Correct. Hello, Art Attack. Iris is, come on, that window, right? Which is controlling that pupil, right? Okay. Ciliary muscles. The muscles which are responsible for thinning or thickening of your eye lens, right? Yes. Human eye and camera. I mean, human eye, they just self-adjust this one, right? Cameras are limited. Our eyes are cameras which, I mean, if you love photography, you might understand what you see from your eye. It's very difficult to capture it on camera as such, right? Best cameras we have. Zooming might be a problem, all right? So, retina, it is the screen of your eye, I mean, right? The screen of our eyes. And you know what, there is a blind spot as well. And there are multiple activities on YouTube to test your blind spot. They would say, watch over here, and this thing will just suddenly disappear, right? So, you can try that. Yes. Don't see color, you will understand right now. Don't worry. So, retina, the layer, it has two types of cells. Rod cells, which are sensitive to light, colors, right? And, which are sensitive to light, but dim light, right? When you are watching your room in very dim light, almost it's dark, you might have noticed, suddenly if you turn off the light, everything looks dark. But slowly you start seeing things, right? Rods are getting activated over there. Next set of cells is cone cells. These are responsible to see color. Yes, cones and rods, right? Cones and rods. So, now when you are saying a lot of animals don't see, cone cells is the reason, right? Now, persistence of vision. This is another very important and very good activity. I mean, film making and watching movies in theaters for a very long time is happening because of this. The impression of an image persists on the retina for about 1/16th of a second. So, you might have seen these things, and apart from, this is a little sophisticated and complicated. Why we have two eyes? You know what? There is a video on Byjus channel about this. I mean, you will see the difference. Why we have two eyes. Don't worry, watch it. It's very nice. So, what do we call these type of books? We call them, come on, flip books, right? Yes. And what is happening? You understand, your brain knows that each paper or each booklet is different. But when you are turning it very quickly, what does your brain interpret? The character is dancing, right? It's dancing, but it's not. What is the reason? Persistence of vision, right? You are turning it very quickly. Yes. Nice, Papia. Yes, AP All-Rounders. You gave the very correct answer to perceive the 3D world. Very good. All right, guys. We have brilliant minds over here in this session. Nice. I'm really happy to have you. Come on. So, we are clear with human eye. All right. What did we learn? We learned the parts: cornea, iris, pupil, ciliary muscles, retina, blind spot, their functions, and we understood about persistence of vision as well. All right. Next set. I mean, we are talking about human eyes. So let's talk about the next stop, right? The next stop is optical and non-optical aids. See, I won't go into much detail, but let's talk about what kind of defects you can have, right? First is a normal eye. I mean, you can understand mine is not a normal eye, right? So, normal eye can see far objects and near objects clearly. It's a normal eye, all right? There are two defects, nearsightedness and far-sightedness, right? And you know what? I'll tell you a way to remember this. Nearsightedness. Nearsightedness means when there is a word near in this, it means near objects are clear, far objects are not clear, right? That is nearsightedness. And all right, far-sightedness. Far-sightedness means things which are far from you, they are clear. Things which are near to you, they are not clear. Fine. So nearsightedness, far-sightedness, fine. Omar, yes. And you know what, Omar, same with me. I also have far-sightedness. All right. Yes, Ashish, you're right over there. And far-sightedness is called hypermetropia, right? So these are defects, but they can be corrected using suitable lenses, which I'm doing, right? I'm using a lens. Fine, okay. Next, cataract. This is one more thing. I mean, what is cataract? Can you tell me? The lens starts to become opaque. Slowly, it happens with age. You know, in Hindi we call it motiabind, right? So that's I would say that's a born defect, attack, right? Yes. Yes. Mix is called presbyopia. You are right over there. Very good. Very good. All right. Okay. Yes, with old age. All right. So cataract. What is happening in cataract? Come on. Come on. Think. The lens is, yes, cloudy image. You were right over there. Cloudy image. All right. Okay. So then what is the solution to this? Solution would be, I mean, eye lens is getting opaque. You have to replace it then, right? Yes, you have to replace it. So these were the defects of eyes. Now this is something so that you might not have these defects is, yes, Adira, you are right. Cloudy images, cataract. How to take good care of the eyes? All right, let's start. First of all, eat food that is good for the eyes. Can you tell me which food is good for the eyes? Yes, change the lens is the only answer. Surgery, yes. AP All-Rounders, you are right. Come on, tell me. Which, I mean, when we say good food, what good food? And I'm pretty sure the foods you will mention are the foods you usually hate, right? I mean, when I was small, I did not like a lot of spinach or carrots. Yes, carrots. Yes, food rich in vitamin A. You're right. Green vegetables, Gauri, you're right over there. Yes, carrots, citrus fruits, all these things, nuts, eggs. Always read from minimum distance of 25 centimeters. Whenever you are reading, a lot of times I have seen a lot of students, they tend to read like this, right? Very close to the book. Don't do it. Minimum 25 centimeters of distance, always maintain it, right? Yes. How many of you like spinach? Yes, yes, okay. Because beyond, I mean, if you take it below 25, right, your lens can't cope up with it. It has to strain itself a lot, right? So that's why wear safety glasses while working with the chemicals. And I think this, you know, like in schools when we are working in chemistry labs, they give us those safety goggles, right? Yes. Yuck. All right. Yes. Fine. Now, what are the don'ts? This is something which we should do. What we should not do is, first of all, look at a powerful source of light directly. I mean, don't see sun like this. Don't see a light, very, very nicely glowing bulb. And you might have also heard our parents tell us when you're passing by and there's some welding happening, don't look at the welding, that spark directly, right? Because it's a very bright light. It will harm your retina, right? Those cells. So that's why. Don't look at a powerful source of light directly. Don't rub your eyes. Alright, don't rub your eyes. And when we say rub my eyes, is not that slight rubbing. Sometimes, you know, we have an habit of doing this rubbing of the eyes. That's not good, right? Yes, it hurts also, Suhani, right? So, and don't read in dim light. Always have proper lighting when you are reading something, right? So that is how to take care of the eyes. And I'm sure you will do it, right? Come on, it's very important. And I mean, I got the specs in what? In class 11th, if I tell you. Yes, don't read in the dark. And don't rub your eyes, Tariq. Yes. Now, here comes a system. I mean, when there is a system, I mean, if you're blind, so for blind people, for visually impaired people, we have a system so that they can read things, I mean, if they can't see. So this is what we call as a Braille system. It's a 6-dot system. You might have seen there are books with this, you know, they can sense with their fingers and they can understand the characters. It's has 63 dot patterns and depends upon recognition by touching. All right. So this is, yes, this is the Braille system. All right. So what did we learn over here? We have learned defects and their corrections. We have understood how to take care of the eyes. We have also learned what is Braille system. Nice, Louis Braille, right? All right. Ayushi, it will hurt the eyes. I mean, you know, the cells, they are not meant to sustain such a strong intensity of light, all right? So, the line which we always say, and you know what, we mean it when we say it. We have got you covered, don't worry, all right? You have got a next session. The next session is visualizing solid shapes on December 30th. It's a Thursday at 4 p.m. All right, guys? No song. All right, so, and I told you, there is a short video on this. Let's make infinite light lamps. It's a very nice video. I mean, I tried this and it feels really great. So I would say next Diwali, try it, keep it in your home. Whatever guests will come to your house now, they will be really impressed to see it. That's a very nice thing. So I would say recommend you try it, all right? Okay. So with this, I would say follow the channel. There are a lot of experiments we are posting. There are a lot of activities, brain boosters we are keeping. It's all for our engagement. It's all for so that we can form a community, right? Where we interact in science, all right? PCM lover? No, I am from 93G. All right. Okay, guys. If you ask me, I'm really glad we did this today and I was so happy to meet all of you. So I would say enjoy Christmas and all the best for the coming days. All right. Bye-bye, everyone. Good evening.